Hello, this video is going to go through an example of calculating an average rate of change and an example of calculating an instantaneous rate of change. So the first question here is to determine the average rate of change of the function g of x equals 2 to the exponent negative x over the interval x is from -3 to -2. So we already know that an average rate of change means we're looking for the slope of a secant line. So on this graph, we've drawn the secant line that goes from an x value of -3 to an x value of -2. And so when we calculate the average rate of change over this interval, we're looking for what is the slope of that secant line. So to determine the slope of that secant line, we know that the formula for average rate of change is the function g evaluated at -2, so the end point of this interval, minus the function g evaluated at the x value of -3, which is the beginning part of this interval, divided by -2 subtract -3. And this is really just our formula for slope, because we're calculating the slope of that secant line. So to determine the average rate of change here, we first need the function values at g of -2 and at g of -3. If you already have the graph, then you can pick those values off of the graph. If you're working just solely from the equation, then you want to show those calculations first for those values for g of -2 and for g of -3. So g of -2 is 2 to the exponent of negative, and then we put in our x value, which is -2. So this is the same as 2 to the positive 2, which is the value 4. And if we evaluate g of -3, then we get 2 to the exponent of -3, which is 2 to the exponent 3, and that is 8. So now we can fill in these values in our calculation for the average rate of change. So we get g of -2 was 4, minus g of -3 is 8, divided by -2 minus -3 is 1. So we get an average rate of change over this interval of -4. Okay, next we'll do an example of how to determine an instantaneous rate of change, and we're going to use the same function. Determining an instantaneous rate of change means that we're looking for the slope of the tangent line that goes through that point on the graph. So if we want the instantaneous rate of change at x equals -3, then we want the slope of the tangent line that goes through that function at x equals -3. So that's shown on this graph here. So when we calculate an instantaneous rate of change, IROC, short for instantaneous rate of change, we are calculating that based on the formula. I'll use g because we're working with the function g here. So g of a, which is the particular value we want to look at. So here we're going to use -3. So g of -3, and we're going to add some very small values. So let's add 0.001. So the value that you put in here isn't all that important. We're going to use 0.001 as our default small value, but really we just want to be able to add any small value to that -3. The idea here is that when we calculate this rate of change, we are getting an approximate value for the instantaneous rate of change based on if we had secant lines where the second point on that secant line got closer and closer and closer to -3, the best estimate would be if we can pick a very, very small value that we add to -3 and find the secant line from -3 to that value. Okay? That would give us the best estimate at what the slope of this tangent line is. So this is just one way that we can use to estimate the instantaneous rate of change. So we know that -3 plus 0.001 is in fact -2.99. So I'm going to put that in the denominator here. So -2.99 subtract -3. Okay, so in other words, we're looking for g of negative 2.999, negative 2.999 minus g of negative 3 over, and if we do this subtraction, negative 2.999 subtract negative 3 gives us 0.001, which was the size of that small value that we're adding to get the interval for where we're calculating our slope. So I need to calculate g of negative 2.999 and also g of negative 3, which we already have from the previous page. So g of negative 3 we know is equal to 8. And g of negative 2.999, we're going to substitute that x value into the equation of our function. So we get 2 to the exponent of 2.999, which is approximately 7.9944567439. And we're going to try and use as much accuracy as possible when we do this estimate. So filling those values in our formula here, g of negative 2.999 is 7.9944567439 minus g of negative 3 is 8 divided by 0.001, and that calculation works out to negative 5.5432561. So this value here is the instantaneous rate of change of the function g of x at x equals negative 3.